Hello, boys. The cosine rule now. The cosine rule is used when we have three sides and one angle, one of which is unknown. So it's slightly different from the sine rule. It's more complicated, but here is the proof of how we get this equation on the right here. Okay, so it's a squared equals b squared plus c squared minus 2 times b times c times the cos of a. So lots going on there, but if you look at the triangle on the left here, it's very similar to what we use for the sine rule. The only difference is the length A to D, I'm going to label as M, and the length of A to B again is C. So therefore the length of D to B is C minus M. If we have to apply Pythagoras here, we're going to look at triangles ADC separate to triangles CBD. So first of all, we're going to form an equation, okay, and what we're going to do is make the subject of H, okay, important. So if you remember your Pythagoras, H squared in triangle ACD is equal to B squared minus M squared, using those side lengths. Now, if you look at equation 2 from triangle CBD, you'll see that H squared, sorry, the pen's playing up, H squared is equal to A squared minus C minus M squared. Now, that looks very complicated, right? But stick with me, you'll be right. What I need to do is equate equations 1 and 2. So 1 is equal to 2. That is the reason I've made H squared the subject, because you can straight away make them equal. So we get B squared minus M squared is equal to A squared minus C minus M squared. Now, be careful. We have to now expand this bracketed area of C minus M squared. So do it slowly with me. B squared minus M squared, the left-hand side stays the same, is equal to A squared minus all of this. Now, C squared minus 2CM plus M squared. Now, we then have to take account of this minus here on the right hand side. So B squared minus M squared is equal to A squared minus C squared plus 2CM minus M squared. Now if you add M squared to both sides, you'll get B squared is equal to A squared minus C squared plus 2CM. Now we're getting closer. If you can look at that, now, just have a stop and look at what equation we need to actually get to. We're pretty close. The only difference is we've got M instead of the cos A up the top, okay? What we're going to do is just look at triangle ACD again, and we need to find the value of M, okay? And if you're looking at where we're headed, it's going to be something to do with cos of A. So up here we continue, and I'm running out of room, so bear with me. We've got the cos of angle A is equal to M over B. Rearranging, B cos A is equal to M, multiplying both sides by B, and that's what we needed. We needed to get M. So subbing into our equation down here, we've got B squared equals A squared, sorry. I'll just rub that out so it's a bit clearer. b squared equals a squared minus c squared plus 2 times c, I've written this a longer expansion, times you're subbing in what value you have here for m. So you got b cos of a. Rearranging, we want to make a squared the subject, so a squared is equal to b squared, adding c to both sides, c squared, and then subtracting 2bc cos. I'm going to rewrite this down here a little bit further. Minus 2bc cos of a. And there it is. That is the same formula as up here. So again, boys, 3 sides, 1 angle, 1 unknown. This is the rule you use. You won't be asked to prove this. It's just good to know because you're in the advanced class. Okay, thank you, boys.